Okay, so the previous two examples didn't require any C4 skills. We could deal with those using our C3 integration skills. Let's take a look at this one. If I look at the denominator and try and differentiate it, I get 2x minus 1, which means that it isn't going to cancel using the substitution to get rid of that x minus 2. So this now is a question that those C3 skills will break down on. Leads us into these C4 skills. So the first thing that I want to do is factorize that denominator. So I'm looking for two numbers that will multiply to give -6 and add to give -1, and they will be -3 and +2. So that is what I'm now going to need to integrate, and at this point I deal with the partial fraction. So it's a linear factor, pair of linear factors. So x minus 2, x plus 2 is going to be equivalent to constant over the x minus 3 plus a second constant over the x plus 2. When I combine those, I end up with that. Now I'm filming this just after we spent a number of weeks on partial fractions, so that should make sense. However, I should have explained what was happening there in case this is 8 months later. So we're dividing the x minus 3 into that common denominator, leaving me the x plus 2. So it'll be a lots of x plus 2. When I divide the x plus 2 in, it leaves me the x minus 3 to give me that. The denominator is the same, which means the numerators are also equivalent. So that means that x minus 2 has to be equivalent to x plus 2. You have a choice of methods where to go from here, whether you choose to form simultaneous equations, or probably with this one we can just choose values of x that make the terms go to 0. So if I let x equal 3, that will go to 0, and I have 3 minus 2 is a 3 plus 2. So 1 equals 5a, a equals 1/5. And if I let x equal -2, the a term will go to 0 and the b term will be -5b. So b will be -4 over -5 will be 4/5. So this means that my integral, rather than writing it like that, I can write it as a 1/5 over x minus 3 plus b 4/5 over x plus 2 dx. We've just got constants there, so that's the same as taking a fifth out and integrating x minus 3 with respect to x, plus taking the 4/5 out and integrating 1 over x plus 2 with respect to x. So these are just natural log of the denominators. So if I can just squeeze that up here, so the integral becomes 1/5 natural log x minus 3 plus 4/5 natural log x plus 2 plus some constant c. You could use the laws of logs to combine that further. You could take out a fifth, but given that it's not a show that, that's probably as neat as you would want it. If we took the fifth out, then you could write it as x minus 3 multiplied by x plus 2 to the power of 4, bringing that, using the laws of logs, that 4 becomes a power of 4. So you could write it like that, but I don't think it makes that much difference if it's not a show that. So that now is, we're at the C4 stage, where our newfound ability to use partial fractions has opened up a door to a whole new family of integrals that we can deal with successfully.